Welcome to Study Loop.
So we have two particles, particle 1 and particle 2. At t equals to 0, we are given that the first particle is at origin. So this means x1 equals to 0, y1 equals to 0. And we are not given the mass of the particle 1. And the particle 2 is at x2 is equals to 0 and y2 equals to 6.0 meter. And the mass of the particle 2 is given, which is 0.5 kg. We have used SI units here, and we are also given the center of mass has position x centimeter, which means the position of the center of mass on x-axis is 0, and y-axis we have 2.4 meter. We are also given that velocity of the center of mass, VCM, we have 0.75 t square meter per second cube. We should have cube here. So to make a dimension correct, we have this velocity of the center of mass in x direction. So we have to find out the mass of the system. We have to also find the acceleration of the center of mass, and we also have to find the force on the whole system. So first, let us approach the first part. We need to find the mass of the whole system. So we have m, total mass of system, must be equals to m1, the mass of the particle 1, plus mass of the particle 2. We can use the formula. We have xcm equals to m1 x1 plus m2 x2 over m1 plus m2. So this is the formula of the center of mass. So we can calculate the mass here, but we are given that xcm is 0, and also all the positions are 0. So this becomes equal to 0. So we cannot use this formula to find out the mass of the system. We can use the second formula. We have similar formula, ycm equals to m1 y1 plus m2 y2 over m1 plus m2. And we are given that y of center of mass is 2.4 meter. So let's put 2.4. We have m1. This is m1. This is we have y1 equals to 0. So this equals to 0. We have y2 equals to m2. We have the 0.5 to 0.5 kg, and y2 is 6 meter. So this over m1 plus m2. So we can calculate m1 plus m2. Putting the value of m2, we have 0.5 into 6. This is a multiplication symbol, cross one, and 2.4. So this gives m1 plus m2 equals to 1.25 kg. So that's the mass of the whole system, m1 plus m2. Now we will find out the acceleration of the center of mass. We know that ACM, the acceleration of the center of mass, is equals to dv cm over dt. So this is the differential of velocity of the center of mass, and we are given that this is 0.75 t square. So we can differentiate it. So this is differentiation is, we are taking the VCM and putting it 0.75 t square, and the differentiation of t square is just 2t, and we multiply the time here. So this is just 1.5 We have t left here, and the dimensions are meter over second cube. Remember that this acceleration of the center of mass is time dependent. We have 1.5 t meter per second cube. At different time, we have different acceleration. So if we want to find out the acceleration at t equals to 0, so we place it t equals to 0, and this is equals to 0. At t equals to 1 second, we have 1.5 meter per second square. At t equals to 2, we have 3 meter per second square, and so on and on. Now we need to find out the force on the whole system. Force on the whole system is equals to mass of the whole system, which is m1 plus m2, multiplied by acceleration, which we have already found out. So this is equals to 1.25 multiplied by 1.5 t. This is also time dependent. We can put the value of time to find out the force at different time intervals. Remember that the velocity of the center of mass was in x direction, so the acceleration is also in x direction, and also the force on the system is also on x direction. I hope you have understood. So thank you.